Thank you very much, Neil. It's interesting, particularly with your last story, to see how much the ocean technology community feeds research, which then feeds technology back out into industry, and sort of that cyclical relationship is really interesting. Next up, I'd like to ask George Kendrick with Stantec to join us.
Okay, let me close. Everybody who's nodding off, stretch. Raise your hands. Okay, go get some coffee. This is really cool stuff. I don't know about you, but I'm just excited by all the technology that's being developed. I'm not an engineer. I use it, but there's no way in hell I could ever invent this stuff. It's just fabulous what everybody's talking about. I'm going to talk about a little different topic, and that's how we're using the technology, not inventing it. Okay. Again, I want to thank everybody who's organizing this conference for inviting us to participate in it. I'll run through a few quick things about Stantec. Some of you may not know who Stantec is. I'll give you a quick overview of that. What do we do? Where do we do it? And I mostly want to spend the bulk of time talking about some projects we're working on that are pretty cool, and some of you might be very interested in helping us generate similar kinds of projects that are collaborative between academic, NGO, government agencies, and private sector. So we're trying to bridge that role, and then talk a little bit about project opportunities at the end. But first of all, who are we? Stantec's a fairly large Canadian-based, founded in Edmonton company. We're now about 15,000 employees. We've got about 250 offices worldwide, and we do a wide range of services. We've got 20 offices and 1,000 professional staff in New England and Atlantic Canada. So we have a pretty strong presence, and we've been here for a very long time. The kinds of work that we do, a large piece of what we do is environmental sciences. And that's what I'm going to be spending the rest of the talk on, is how we use technology in the marine environment for our environmental studies. We've done about 6,000 projects in the region in the last decade, so we have a lot of experience, and we have particular expertise in marine ecosystems. We have a very strong marine team. They're scattered throughout North America. Our leaders are. We have projects that are cross-sector and cross-border. And I want to emphasize the cross-border aspects. Not only are we a Canadian company with about 8,000 employees in the United States, so the border doesn't exist for us, but for environmental studies, wildlife don't care about political borders. They travel, they migrate, they feed. Global warming is affecting the location of many of them. So we find that we need to pull teams from across borders and across regions to work on projects, and the projects themselves are crossing borders. This is just a quick overview of some of the leaders that we have. Again, we have about 1,000 staff in New England, the Maritimes, and Newfoundland. But we have special leads that are scattered around North America that are the discipline leads in their technical discipline. They're experts, they have advanced degrees, a lot of research experience, and their responsibility is working with clients to solve problems, assemble teams, ensure quality control, and they draw from the rest of our staff across North America. So what do we do? Well, we work for a lot of different clients in a lot of different sectors. Oil and gas, a lot of them have been mentioned today already, the kinds of private entities for the most part, but also public governmental agencies that we work for. We do a lot of work in oil and gas, pipelines, a lot of underwater pipeline work. We did a lot of work in Sable Island. We're working in Newfoundland now. We do a fair amount of work on renewables, minerals, mining, generation, etc. Ports and harbors is a big piece of what we do also. And the kinds of work that we do, these are coastal resiliency projects, permitting. We deal with contaminated sediment, evaluating plumes, movement, ecological effects, water withdrawal for power plants, and we do baseline studies in almost every topic that you can imagine. And we work with a lot of subcontractors and equipment providers and team members to carry out these projects. And these are the kinds of services we offer. I'm not going to go through the list, but it's almost everything you could imagine for a project. We usually will design and implement the program. I want to talk a little bit about our methodologies, because this is where the technology comes into play. What we do is we work at the interface between science and the regulatory environment. So in many cases, we have clients or agencies that are trying to develop a project, implement a program, and they have to either get a permit for it, they have to comply with something, They have an operating facility that needs to remain in compliance. And in all of those cases, they need to evaluate impacts to the environment. But, and this is key, the client doesn't need a quarter-inch drill, they need a quarter-inch hole. So what we try and do is figure out what is the problem, what is the question, and then we'll go back to try and figure out what's the best solution. And in many cases, it's using simple, time-honored techniques. It's sort of the Occam's razor approach. But there are cases, particularly in the marine environment, where we have to rely on technology for several reasons. One, safety is a critical aspect of our company. We have very high-risk, dangerous environments when we're working far offshore. The more that we can use technology, remote sensing, the safer it is for our staff. So we're using a lot of remote sensing, hydroacoustics. We're using a lot more AUVs than we ever did before. This is saving our divers from having to go down in dangerous conditions in deep waters and cold conditions. We do a lot of GIS analysis. We're also doing a lot of DNA testing now for species identification that's faster, allows us to identify some cryptic species, the differences between some marine worms, and it saves our people's time from having to be out on the boats as long. And we're doing dispersion modeling, a lot of complicated computational fluid dynamic modeling. So there's a lot of things that we do now that are using technology to answer the questions. And I've talked a little bit about the remote sensing and sampling. The AUV use, this is an old one actually that we're looking at on the right-hand side. This is particularly important in our Arctic program that I'm going to talk about in a moment. Putting divers down in extremely cold water with strong currents in areas where we don't have all that much bottom information, it's a lot safer for us to use AUVs for that. Okay, now I want to spend the time talking about projects because that's what's the cool stuff. First one is Newfoundland. So you heard earlier about some of the projects in offshore oil and gas in Newfoundland. We've been working for the last 10 to 15 years offshore in Hibernia, and we're talking 200 to 300 kilometers offshore. This is a tricky environment to work in. And what we're doing out there is water quality monitoring, sediment dispersion. We're looking at effluent plumes. We're looking at fish populations, the biodiversity. And to work in that kind of an environment, we have to rely on technology more and more. So we're using a lot of remote sensing devices. We're using AUVs. We're using gliders. We're trying to do sampling, minimal sampling and rapid sampling. This is a kind of offshore oil and gas project where the technology is expensive, but it's providing us actually faster data collection and safer. And plus the oil companies need to answer the questions. And so they're not quite they want to make sure we're answering the questions, and the cost is not as big of an issue as it is for another organization. We're working for deep water wind right now. We've worked on Cape Wind. We've worked on a project in Maryland. Right now we're doing marine mammal monitoring for the construction phase of deep water wind. We're also doing hydroacoustic monitoring for the same purpose. So we're trying to evaluate the impacts on marine mammals, mostly seals, right whales, as the construction project goes underway. The challenge with a project like that is we need to do these surveys 12 months of the year. And working in the offshore in the wintertime, as many of you know, is a tricky, dangerous environment. The problem we have is that for those kinds of surveys, there's no magic bullet. We still need humans standing on a ship deck with binoculars to do species identification. We don't have we don't have an automated technology that allows us to do species identification to the level a human can. So hydroacoustics are fabulous. They give us migration time periods. They give us numbers, but they don't give us the species. They don't give us all the data we can capture on a deck. So there's no real replacement for biologists staying on a deck with very large binoculars at this point. In contrast, we had a project we're just wrapping up that was funded by DOE, and it's a 3-year evaluation of birds and bats offshore. And this is specifically targeting the offshore wind development for the future. There's been anecdotal stories over the years of bats appearing offshore, hundreds of bats clustered around a wheelhouse of a fishing boat 50 miles offshore. Who knew? But nobody had an answer on, well, is that common? Are they there? What species are there? When are they there? Is this a problem? And if we're putting wind turbines out 15, 20 miles offshore, We do need to know the answer to that because onshore, we already know that there's mortality from birds and bats from wind projects. So DOE funded Stantec to lead a project that was basically doing bat surveys up to 50 miles offshore. Now, this is a bit of a challenge because bats fly at night, they're very small, and they echolocate. And the sounds that they make are at such high frequencies humans can't hear them. So the specialized equipment we have to use for this. So we use high frequency echolocation detectors mounted on platforms, solar powered, with either satellite or cell telemetry to transmit the data back to shore. Sounds simple. It took us several years to develop an array that was waterproof enough to survive in a marine environment. And what we did for this study was we developed a consortia of folks to help us, and Naracus was a partner on this, where we deployed 40 arrays on ledges, lighthouses, islands, weather buoys, and ships from Maine, where we had 24 sites in the Gulf of Maine, mostly using Naracus buoys, but also some offshore ledges, including Matinicus Rock and places like that, Mount Desert Rock. The Mid-Atlantic, we had 8 sites down there, and we did the Great Lakes as well. And what we discovered, I won't go into details on this, but it was a very cool project. We discovered that, yes, in fact, there are bats offshore. All the species that are onshore are offshore. They're following the same migration patterns offshore as they are onshore, but there are fewer of them. And everybody said, well, what are they doing offshore? And what we believe at this point is they're simply filling a niche in aeroecology. They're feeding offshore by following migrating insects offshore. And they're also hopscotching from Canada down on the Maine Islands through the Gulf of Maine and working their way down the Atlantic coast. So bats live a long time. They can live up to 30 years. They have a very low reproduction rate. They only have 1 or 2 pups per year. So it's an endangered, some of them are endangered on the endangered species list, and it's an important topic. I'll talk a little bit later about who worked with us on that one. And the last one I want to talk about is the Marine Arctic Ecosystem Study, which is very appropriate considering our lunch talk today. Stantec was selected by BOEM to lead an Arctic ecological research program to try and understand the entire ecosystem off of Alaska and through the Arctic through the Chukchi Sea. And it's a 5-year project that has a large group of consortia of academic research institutions, the Navy, private interests, because the question is exactly what Dr. Sorchi asked earlier. If global warming is opening the Northwest Passage, we're going to be seeing increases in transportation. What are the ecological impacts going to be? We can't answer that unless we know what the hell the ecosystem is and what it's doing. So the initial first year of the study was based on marine mammals, charismatic megafauna, everyone wants to know. So we did capture and tagging of seals at Barrow, and we're tracking them for the last 2 years, basically, and trying to see where they went. And so we were using the latest GPS systems to be able to glue them on their backs. It lasts for 2 years. They're transmitting live data, and they're giving us their GPS coordinates and water depth. So we know where they're going, what their behaviors are, and there were some surprising results on how far these seals were moving, and also the patterns of behavior during the breeding season, where they were foraging, and all of that information is going to be developed into a avoidance model or perhaps marine protection zones. But all of this is going to be feeding into that information. The next phase of the project, which is going to start starts this year, physical oceanographic measurements on a detailed level. We have a lot of moorings being put in right now. We're also going to be using more AUVs and gliders. We're going to be gathering information off the Mackenzie River Delta, which is a huge source of nutrients coming into the Arctic. And just like you heard earlier, the whole question about nutrients coming in and out of the Gulf of Maine, this fabulous information we have for Maine, for the Gulf of Maine, we don't have it for the Arctic. And so we need to understand what is happening as the nutrient loads coming in from the Mackenzie River into the Arctic, and is the phytoplankton, ichthyoplankton, and all the way up the food chain being affected by this pulse of nutrients coming in? Where does it go? How does it move? So the first test is looking at physiographic or physical oceanographic measurements. The next task is going to be looking at chemistry and nutrient loads, and all of this is going to be done through buoys and AUVs because it's too cold for us to be diving up there. It's a very cool project. We're very excited to be leading this one. You'll see the list in a minute of who else is involved in it. It's a bit like herding cats, but it's a very strong group of folks. Is that going backwards? Technology again. Okay. Last quick thing on projects. Stantec does a lot of international work as well. This is just a quick list of some of the projects where our marine science teams have been working. It's basically all over the world. We bring that information back to our local offices, so what we learn in Papua New Guinea or we learn in the Caribbean, we will be able to apply here. Okay, opportunities and collaboration. I want to leave you with some thoughts on partnering. And if there's things here that strike your fancy and you see your own organization interested in participating, we want to know, we want to talk to you. We have a long history of developing community partnerships and academic partnerships across North America. We have Aboriginal partnerships in Canada where we partner with First Nations within their territories to develop projects, do ecological studies, develop infrastructure. We haven't done as much of that in the States. Stantec has really only been in the United States for about 8 or 9 years, so we're going to be hopefully moving there. It's a little different situation in the States versus the First Nations in Canada. But the other thing is we have collaborations with private and public entities. So the Orca Collaborative up here is a relatively new one for us. We're working with Baird, which is a marine engineering firm, and Search, which is one of the foremost marine archaeological groups in the United States. And we formed a partnership to do primarily federal projects, bringing Stantec's environmental, Baird's engineering, and Search's archaeological work together. That's the kind of private collaboration we do. On the research side, this is what we did for this offshore bat project. So Naracus was great in providing us with access to buoys, putting and figuring out how to put remote-powered bat detectors with telemetry onto existing weather buoys was not something we knew how to do. And so we had tremendous help from the folks who were actually operating and maintaining that system. Ecology Atlantic and UMaine, and there were a whole bunch of folks who participated in this and helped us. It was a great project. And if you just Google, offshore bat collaboration DOE, the final report will come up and it'll give you a sense of how we did it. And this is the Mares group. This is the Marine Arctic project. It's quite a group of folks, all who have an interest in research in the Arctic. Arctic Research Council is obviously very, very interested in this. And the Alaska Ocean Observing System set of buoys is also participating in this. So we're very excited about the kinds of work that we can do. And even though we're a private entity that works for private corporations, we also do an awful lot of research work working for federal state agencies, and we want to partner with more academic institutions and research groups. And if you've got any interest in that, I'd encourage you to contact Pam Newbert, who leads our U.S. Marine program. You can contact me as well. I'm here in Maine. Pam is in Massachusetts. We'd love to hear from anybody who's interested in partnering. Obviously, we want to think specifically about the kind of project we'll go after, and we want to assemble the best teams we can to make sure we win. But we're very interested in hearing from you, and happy to answer questions afterwards.
Thank you, George. Working in government, that last slide you have is deeply impressive because I know how hard it is just with 2 institutions involved, and the sheer volume we have is herding cats sounds about right.